In this video, I'll be working through the question you see on the screen here from the summer 2025 Cambridge A-Level Maths paper 1-2. I'm going to try and show you how to do this question and not just the solution. So definitely pause and rewatch certain parts if you need to. If you're looking for a different question from this paper or a different paper entirely, you should be able to find a playlist in the description below or have a look around on my channel. Okay, let's get into the maths. Question 11 starts off with a completing the square question. We have a quadratic equation. There's three famous ways to solve these. Use the minus b formula, try to factorize it by adding up different sums in your head, or what we're about to do, completing the square. This is a great way to do it, and indeed you have to know how to do it to get full marks in the exam, because it does come up now and then. How do we do it? We're looking for a number that goes here. Let's put in +2 here, leave a bit of space. We're looking for a number, something that goes here, such that this is a perfect square. And what I mean by that is like x plus 1 squared, that's a perfect square. X minus 3 squared, that's a perfect square. This one would be x squared plus 2x plus 1. So if there had been a 2x here, I would like a 1 to be there, is what I mean. This one would be x squared minus 6x plus 9. If there was a minus 6x here, I'd like a plus 9 here. That's what I'm talking about here. It's actually quite easy to find. 2, I want 1. 6 minus 6, I want plus 9. It's actually half of this number squared. Half of 2 is 1, squared is 1. Half of minus 6 is minus 3. Minus 3 squared is plus 9. Half of this is 2. 2 squared is 4. I would love a plus 4 there. The problem, it's not there. So we have to make it there. Plus 4, minus 4. I haven't changed anything. I've sort of cheated a little. But now I have a perfect square. X plus 2 squared is what that would work out. Minus 4 plus 2 is just minus 2. This is identical to this. This is the completing the square method. If you had equals 0, for example, you could rearrange it, move the minus 2 over, square root both sides. You get plus or minus square root, just like in the minus b formula, but it'd work out quite nicely for you. Okay, let's go on to the next part. Okay, in part B, they give us these two functions, fx, the one we see in previous, and gx. This is, the domain is less than minus 2 and greater than minus 2. First thing I want to do is get rid of this one. We'll replace it with our previous answer from the first part, which is x plus 2 squared minus 2. Let's replace it with that. That was the trick in this question. Okay, then on to the actual question. They want to find an expression for the inverse of x. How do we do that? How I like to do it, you can change it up slightly. I like to write this one again. So we start with the first thing. Instead of fx, I put in y. Y is equal x plus 2 squared minus 2. This is the function, or what's the curve, I guess, when y goes in. It's the original function. To get the inverse, it's just x and y change places. That's all the inverse is. We also think of it as mirroring through the x equals y axis. That's x and y changing places. So I like to do it at the start. You can do it at the end though. So x is equal y plus 2 squared minus 2. Then what we want to do is we want to rearrange this so y is on its own. Get y out in front. Then that'll be our new function. So let's try and do that. We add 2 to both sides. We get x plus 2 is equal y plus 2 squared. We get the square root of both sides. We get y plus 2 is equal to plus or minus the square root of x plus 2. So that is y is equal to minus 2 plus or minus square root of x plus 2. We don't want y to be here. That was just a placeholder. So we replace that now with the inverse of x. This sort of is our answer. We'd get marks. What's it, 3 marks? I think we'd probably get 2 marks for doing this. There's a problem though. Functions don't like plus or minus in them. They like one answer. Put one thing out, one thing in, one thing out. We don't want two different answers to come out. So what's the problem here? What's going on? I reckon there's only 1 mark for this, which I think is a bit mean, because I thought this was a hard question. I thought it deserved a lot more. Fairness, later on the question's a bit easier, and I think the whole paper was actually relatively easy. So maybe it's not too bad. Okay, so what's going on here? We need to think about this. We need to think about the domain and the range. We could draw pictures. Yeah, let me draw a picture of it as well. Why not? Because it's quite easy to draw. This is 0 when x is minus 2. And it's minus 2 at that same point. So we get minus 2 down here, and we get a function like that. The inverse of this mirrored through this. It's a bit awkward to draw, but something like that, isn't it? That goes up, that goes that way. Okay, that's one way. You could do the answer thinking about this, because we're only looking at when x is less than minus 2. So let me get a rag here. So we're actually, forget about this side of it and forget about this side. You could think about this. This function should be this guy here. So maybe you can figure out whether it's a plus or minus. That's one way to go about this. How I think you should think of it is the domain and the range. The domain is what goes into a function. So this goes into fx. Now the inverse, they switch places. So what goes into the fx is what comes out of the inverse. So the range of this guy, fx, the range of fx has to be this. It has to be less than or equal to minus 2. Because if this goes into the function, it must come out of the inverse. So if this here has to always be less than minus 2, think about that. This is a 0, and in fact it's getting bigger, which isn't quite clear, but it is, because what goes into this function is what comes out of this one. It's a little extra there. What comes out of this gets bigger and bigger. It's minus 2 and bigger. Or you could just think of it, it's a square root, it can't be less than 0. That probably helps you a little, but really you probably want to figure out the range of this guy. The range of this was, the smallest this gets is minus 2, so this has to be bigger than or equal to minus 2. You can see it in the picture here as well. Okay, so that's all that can go into this. That means if that's to be bigger than minus 2, this number here has to be 0 or bigger. This one gets bigger and bigger here. It's also, they wouldn't have given you a number that made a complex number anyway in paper 1. Okay, I might have lost you there. All I'm saying is we need this, all of this, to be less than minus 2. So that means, and this guy here has to be bigger than 0. That's all I'm trying to say with the last minute or two. So it's minus 2 plus something bigger wouldn't work. It wouldn't give us something bigger than less than minus 2. So this has to be a minus. So the answer they want to see, it's okay to write this, but your final answer has to lose that plus. They need to see minus 2 minus square root of x plus 2. Let me go over that one more time. What went into fx is what comes out of the inverse. So what comes out of the inverse has to be less than minus 2. So that means we can't add on a number to minus 2. So we can't have that plus. That's the answer to part B. I think that's worth way more than the 1 mark extra you probably got for it. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Right, in part 2 they ask about the compound function g of f and the inverse of it. And they want us, find an expression for this. Okay, let's do that, but first let's go back a bit. Let's find the function, the expression for g of f, first of all. I like to rewrite that. That's the same as g of fx. Okay, so let me write it like that. What does that look like? We'll have to talk about the domains and the ranges again, unfortunately. But before we do that, let's just get a rough idea. fx, we know what fx, it looks like this. So this is the same as g of x plus 2 squared minus 2. That's all. What does g do? G, this tells us what g does. Whatever is in the brackets, we get minus of it and we take 4 away. That's all. Whatever is in this brackets, we put it to a minus. So minus x plus 2 squared minus the 2 as well as plus 2. And then we add 4 onto, sorry, we take 4 away from all of that. Because that's what g does. It turns it to a minus and it takes 4 away from it. We can clean this up a little bit. That'll be minus 2 minus x plus 2 squared. That's what g of x looks like. I could wait a little more, but at this point I would like to talk about the domain of this compound function. Yeah, what we previously said, we actually already said the range of fx. The domain is less than that, and the range was bigger than bigger than minus 2. That's important. They didn't really ask about it, so it's not that important. You're not going to lose too much marks. But for this function to work, what comes out of fx has to be allowed to go into gx. Because what comes out of fx goes into gx. And what comes out of fx is always bigger than minus 2. And that is what's allowed to go into gx. So I just wanted to mention that first of all. Next, I'd like to talk about what's allowed to go into gx then. G of f of x, the compound function. It's the same thing that's allowed to go into fx. Because we start with fx, right? We can't get to this compound function without putting something into fx. So that has to be allowed. I then just said, well, gx is allowed because what came out of that. They didn't ask any of this, but you sort of needed it for the next bit. So the range of this guy is the same as the range of fx. So the range of this is less than or equal minus 2. So to get the inverse, it's just like the last part. So I said you deserved a few more marks in the last part. Well, we get to do it again, so you pretty much get double marks. The inverse of this guy here, let's write it as y is equal minus 2 minus x plus 2 squared. Change parts. X goes over here and y goes in here, and rearrange it. So let's see, add 2 to both sides to get x plus 2. Will I have room here? Hopefully. X plus 2 is equal minus y plus 2 squared. Multiply both sides by a minus. That's a minus and that's a minus. Get the square root of both sides. So that becomes, let's switch them as well. Y plus 2 is equal to the square root of minus x minus 2. And that's plus or minus. We have to go through this dance again. We have to decide which of these to use. So the final answer is y is equal minus 2 plus or minus the square root of minus x minus 2. And again, instead of y, this is actually g of f, the inverse of g of f of x. We just need to decide, is it a plus or is it a minus? But again, just like before, what goes into g of x is what comes out of this guy. What goes in is less than minus 2. What comes out of this has to be less than minus 2. So minus 2 cannot add anything to it. We can't add anything. So the plus needs to disappear. Your final answer has to be this line without the plus. So I said, yeah, I did say that deserved more marks. You pretty much got the mark twice because it was the same trick twice. Okay, that's it for question 11, and that's it for this exam. If you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day.